So we did adding and subtracting as well as multiplication of polynomials. Those were all pretty similar to complex numbers, pretty straightforward. Really what it is just being careful about the negatives when you subtract, and when you multiply, making sure that you multiply each term by each term in the other, whatever you're multiplying by, right? So pretty straightforward stuff. Again, just like complex numbers, when we're dividing polynomials, it's a little bit more difficult and it's a little bit more involved. And so really what dividing polynomials is for us is a method for us to completely factor higher degree polynomials. So we can factor quadratics. We could use completing the square. We can use that sort of thing. But on higher degree polynomials, that becomes somewhat more difficult, right? So polynomial long division is a way for us to completely factor out polynomials, right? So think about if I were to, I don't know, divide 100 by 4, right? I'm going to write this out as long division. 4 goes into 10 twice. So 2 times 4 is 8, and then I subtract, and I'm left with 2. Bring down the 0. 4 goes into 25 times, right? So what this tells us, sorry, I guess it's 4 times 20, so on and so forth, remainder of 0, right? So what this tells us is that 4 times 25 is equal to 100, right? Another way to think about that is that I took 100 and I factored out a 4, right? And I was left with a 25. So I could then take 25 and I could factor something out of 25. And if I were to factor something out of 25, then maybe I'd have 5 times 5 is equal to 100, and so on and so forth, right? Same idea here where, I'll take a polynomial and I can factor out one binomial, and I can keep doing so. So like if it's a 4th degree term, I could potentially factor out 4 binomials, okay? And then what I get is I would take something that's x to the 4th and be able to write it as x plus or minus something times x plus or minus something 4 times, right? So that's the goal of polynomial long division. Now, polynomial long division is a little bit tedious, a little bit long-winded. So I'll do an example here. I'll probably have another example video. We'll see. Maybe we'll do a couple examples. So yeah, let's do 2 examples. So we'll look at the first one here. Okay. So I want to take x cubed minus x squared minus 2x plus 8 and divide that. I don't like the division sign, but we're going to use it by x minus 1, right? We're going to write this as a long division problem, right? So I'm dividing by x minus 1. So like if I took 100 and divided it by 4, just like I previously did. So this is going to go inside and then dividing by x minus 1 out here, okay? Now, when we're dividing, what we want to focus on is this term, the highest degree term that in the term that we're dividing by, and then the highest, and then the highest degree term that we have left inside the divisor thing, whatever that's called. I can't remember what it's called. So my highest term inside is x cubed, right? Outside I have an x. So the question I want to ask myself is, what do I have to multiply x by to get x cubed? Okay, well, I have to multiply I have to multiply x by x squared to get, so when I multiply those together, x squared times x gives me x cubed, right? But I also have to multiply it by the minus 1, right? I can't forget about the minus 1. So then negative 1 times x squared is negative x squared, okay? Then, just like we would normally do, we subtract, but I have to make sure that I change the sign of both terms. right? Because I'm subtracting both terms. So when I do that, the larger term should cancel out, and then I've got, ooh, this is interesting. I've got negative x squared plus x squared, which should cancel each other out, right? Leaving me with 0. Okay, that's all right. What do we do? Well, we just bring down terms until we have the same amount of terms as we have over here. Okay, so I'll bring down the negative 2x, and I'll bring down the plus 8, right? So now I've canceled out the x cubes, I've canceled out the x squareds. Now this is my largest term remaining, and so I want to say to myself, what do I have to multiply x by to get negative 2x? Well, I have to multiply it by negative 2, right? So negative 2 times x is negative 2x, and negative 2 times negative 1 is positive 2, right? But then I have to change the sign on both of them, right? Because I want to subtract both terms, so that becomes a positive. That becomes a negative, and negative 2x plus 2x cancels out, and then I'm left with 8 minus 2, which is 6, okay? So now, here's where we have to draw on a little bit of our previous knowledge, right? I can't divide 6 by x, right? There's no x there, so this will be our remainder, okay? I don't know if you recall remainders, right? But 6 will be our remainder, so we have left over. And so what we do is we take our remainder, which is 6. Oh, that has gone poorly. Just 6, and we divide it by x minus 1. Right? So my solution, what I ended up with was x squared minus 2 plus 6 over x minus 1. Okay? Now, important bit of information, if I were to take what I got, okay, x squared minus 2 plus 6 over x minus 1, and multiply that by what I divided by, x minus 1, I should get back out my original polynomial, right? So that is something to keep in mind, okay? So we'll dive deeper into actually factoring polynomials, but for now we're just going to work with practicing polynomial long division. So let's look at one more. Let me see if I can find one that works here. Okay. So this will be example 2. I've got negative x cubed plus 4x squared plus 9 divided by x minus 3, okay? So this is where it's important to keep in mind, you guys remember we talked about standard form. We got to look out for any missing terms that I may have, right? I've got x cubed, I've got x squared, but I don't have an x term, so what I want to do is rewrite this x squared plus 0x plus 9 divided by x minus 3, right? What happens when we divide by polynomials is sometimes lower degree terms pop up. So sometimes an x term will pop up, and if we completely ignore that, then we're going to butcher our answer. So we got to put in placeholders for terms that may not necessarily exist, or terms that are zeroed out. Okay, and you'll see that potentially they may pop up. So I'm going to take this. I've got negative x cubed plus 4x squared plus 0x plus 9. So it's a third degree polynomial. I should have 4 total terms. X minus 3. So I care about highest degree term, highest degree term. What do I have to multiply x by to get negative x cubed? Well, I have to multiply it by negative x squared, right? So negative x squared times x is going to be negative x cubed, and negative x squared times negative 3 is positive 3x squared, and then we want to change the sign on both of them and add down, so that cancels out my x cubes. Right? Then I'm left with a positive x squared, and I bring down the next term, which is 0x. Okay? So since I've got rid of the x cubes, now I'm looking at the x squared. What do I have to multiply x by to get x squared? Well, I just have to multiply it by an x. That one's pretty easy. So x times x squared, x times negative 3 is negative 3x, right? So now we've had an x term popping up. We want to change the sign on both of them and add down. So when we do that, the x squareds cancel out, and I've got 0x plus 3x, which is 3x plus 9. Okay. All right. I got rid of my x cubes. I got rid of my x squareds. Now I'm left with an x term. So what do I have to multiply x by to get 3x? Well, just multiply it by 3, right? So 3 times x is 3x. 3 times negative 3 is negative 9. Change the signs and add down. Cancels out the x's, and 9 plus 9 is 18, right? This is my largest degree term. When I get to the point that my largest degree term that I have left is a lower degree than what I'm dividing by, so in this case, right, 18 is a lower degree. It's an x to the 0th. And so I can't divide it by x. That's when I take that as my remainder. So I take that and bring it up to the top as my remainder. So plus 18 over what I was dividing by, which was x minus 3. So that is my answer, right? And so if I took that and multiplied it by this, I would get back out my original polynomial. Okay? So this may take some practice. Try your best to do a couple of problems. I'll try and make them as simple and straightforward as possible. And then the next time I see you in class, we'll spend some more time going over these. So, yep. Feel free to shoot me an email with any questions. Other than that, I will see you all on Wednesday.